things which are which we have some algorithms, basic algorithms, how to import images, how to import videos. Although we didn't see for the video, we will look into that. We have seen how can be a live streaming can be uh, processed with some algorithms which you want to apply. So in this one, we will be looking into a hands-on code that how you can perform object localization for pick and place application using a 6DF robotic arm. So this is just an introduction for OpenCV, that how you can integrate the OpenCV code with a robotic arm, or how you can basically make your robot realize what are the positions of a particular object, which are initially which are engraved, which are taken into pixel format for the camera, and how these pixels are converted into real world coordinates. So this is just a step-by-step block diagram. We will be taking, first of all, we will be taking a frame, as we have seen that a series of frame will form a video. So we will take each frame and then we will uh, convert that frame into HSV. As we have seen that there are quite a number of color formats we have worked with black and white color format. So likewise, we have another color format HSV, stand for hue, saturation as well as value. We will convert the RGB image which we'll be getting from the camera into HSV format. The reason behind doing so is that there is no priority in that, but your OpenShift algorithms work quite fine with the HSV format image. There is no particular assumption or priority given to any color conversion, but most of the algorithms which you are applying in series will be working quite fine in HSV. Then we will be thresholding the HSV values for our in-range image. For our color sorting, we will look that into our code. Then when we will be identifying the location of our object which need to be located. Then we will be scaling that coordinates and pixels to the real world coordinates and giving the output to the robotic arm, so that via inverse kinematics it will go to that position and pick up the object, and then it will drop it to a required location. Suppose if we have three different basket for red, green, and blue, different colors. So we have already discussed that OpenCV has a variety of applications. We have gesture movement. We can have uh, people. We have self-driving car, another important evolving application using OpenCV. We can have use for face detections. Then these are certain other parameters which need to be kept in mind while working with visual aspects of programming. So not your software works in ideal condition, but to have your software to work into real condition, you have to take up certain other parameters too. So that can include camera pixels. If you increase the number of pixels, the accuracy, the optimization for your code will be very much good. If you work on light intensity, the reflecting surface should be avoided so that it do not detect it as a blue, or it do not detect it as a white colored object. We will look into that when we will be how there are certain levels of errors that we encounter. We will be looking into that when we will be working with our webcams. So then we have camera angle. Of course, camera angle is important because if the workspace and the camera are not placed parallel, then there will be a paradox difference in each coordinate, which will be quite hard to have a calibration with the robotic arm. Suppose if you have two planes parallel to each other, then the distance between them, the coordinates difference between coordinate distance between them will be uh, simply a multiplication scaling factor for each one and will be same. But however, if they are placed at certain angle, then their calculation will be a little bit complicated as well as difficult. But it is feasible. So whichever work you work or whichever work you want to work, things are quite feasible, but it requires some extra calculation and some more uh, parameters which has to be avoided in ideal situation and is to be obtained for the radial situation. So we have RGB value format for a cube where the location, where the uh, position inside the cube defines the color or the location or the values for the RGB values for the color. We have certain things, same thing as in our HSV. We have a cylindrical, solid cylindrical, where as you can picture, you see in the picture that we have hue, saturation, and value. We have hue value for the brightness, intensity, or saturation. I'm sorry, the saturation for intensity. The hue is for different color code. So while working with the uh, in range color sorting, we have to change the value of hue, and we have to define a particular range for its perfection, for its working. So here's a particular tabular representation of how, if you talk about red color, then we have the hex values FF0000, and the RGB values will be, of course, the red will be high, that is 255, whereas G and blue will be 00 for red color. And for HSV, we have H 0 degree, while S and V has percentage of 100 and 100%. So in order to convert the HSV, the RGB value, which we already know, or for which we are mostly aware of, uh, they can be converted into HSV. Uh, However, either way is workable at these days we have digital devices which can simply put forward the direct HSV value of an object if you scan it with some digitalized sensors. So there won't be an issue. But if you look into a calculation, then let's take an example of blue color this time. So we have for blue values for RGB is 00255. And for HSV, we have 240, 100, and 100. So in order to convert, in order to give input to our OpenCV, we will divide the H value. We will divide the H value with 2. I'm sorry. We will divide the H value with 2. So that will come as 120, and the S and V value will remain same, or it can be modified according to the environment. The environmental factors include what we have discussed here: the camera and camera pixels, light intensity. So when the our picture has been is converted into the uh, the in range what we are expecting from an image, so we differentiated with black and white for a better visualization. So in this picture we have been holding a colored object in our hands, and as you can see there are some other background lines which should not be included, but they are coming in picture. So that's something which is deeper, which has to be avoided. Like how to optimize the better optimized code will be quite effective in this working. So that can be done if we want to sort out. Suppose for a simple application which we will be using, then there might occur a number of noises. So we can simply threshold that something we have a block which has a diameter of about suppose 7. So if we calculate the area, that would be suppose we have a radius 7. So if we calculate the area, so that will be pi r square. So that will turn around 22 into 7. So if something which is less than 22 into 7, then it should be avoided for our calculation. However, if something greater than 154, like 22 into 7, so it should be counted. So in this case, we can apply some algorithms which are helpful. And the most important, when you have taken the value, when you have in range value settled here, but the boundary description is not quite clear. The image appears to be quite rough. So in order to overcome that issue, we will use contours. Contours are simply as a curve joining all the continuous points having same color intensity. So, so if you are having a same color which you have defined from in range function, then you can put a contour, a circular boundary around it. But there can be a problem in this case also. If suppose two objects which are two different objects which are not connected or not related to each other but are placed quite close to each other, then the concept of contours might fail or might not give proper results if some other object has a greater height and it has covered the area or boundary of the smaller one. So that is something which require innovative mindset or creative thinking. We can either have two cameras placed or something which is quite helpful for our working application in that case. So finding contour is like finding white object from black background. For this binary conversion is done, as we have already seen in the previous slide. So this is as we in previously we were talking about numpy. So if we relate numpy to here, then these values or these numbers are basically the color on the image. But when they are converted into some uh, algorithms for the PC for the laptop or the project which you are using, then these color values are being converted into the values. These color are being converted into the values. So as you can see, these are 190, different color placed at different location, which have different value indeed. So another application include face recognition, people count. As in this pandemic, if you want to limit the number of people entering the restaurant or the mall, then this that can also be achieved with the algorithms which are used in OpenCV. Another evolution is the self-driving car to avoid uh, people killed on roadways because when everything goes to ideal, but this still has a long way to go. But some of the uh, parameters and features are quite descriptively available in OpenCV. So someone can prepare if he or she wants to have interest, then self-driving car is another important application. We have a number plate recognition in case of automatic traffic lights, function as well as actuations, and these things can be sorted out. Okay, so we will be shifting into the hands-on how we can uh, make how we will be coding for our this color sorting using 60 of robotic arm. So I'll just open the same project which we were previously working on. So I'll just make another file and I'll call it 8.2. Let's suppose. Okay, so initially we'll be doing the repeat theme step. That will be import CV2 and import numpy as np. Uh, we have discussed how webcam can be connected uh, to our video for live streaming, but we want to make something more workable. Let's call it CV2. Let me just. Okay, so now I'll just make it. Okay, so I think there's problem with importing video, so I'll just again repeat with the how we have done in our first experience here about taking image into consideration. So I'll take img and I'll just name it cv2 dot imread, and I'll name it str info type and str png, and then I will convert this image into HSV format, as we have seen that OpenCV work quite fine with HSV. So that would be simply, let's name the variable as HSV and see it and convert it into this format. Taking the values, I will putting the source as img, which is my image address, and I will just convert into VGR to HSV. Okay, so let's see how our HSV format looks like. So I will just write cv2.im show, and I'll write the HSV is this, and this should be. Let us just also see how our normal image looks like, so we can differentiate between the two. I'll just name it this. Okay, so sorry about it. I have opened another. I have run another file. So this one should be this one. Okay. I have to make a delay count. Let's make it cv2 dot key wait key, and let's make the delay of 0. Okay. So you can see that this is my normal image and this is my HSV conversion. That's look quite a raw image, I believe. Let us also make here our black and white, and let us see how these parameters function. So I'll just repeat the same step and make it available. Okay, so I have converted this into black and white format, and then I'll just put the black and white, and let's put the address in BW. So if I run this again, then let's see. Okay, so these are the conversion formats. Black and white is simply we normally encounter, but HSV is not simply which we normally see. So this is how this is HSV format. Something looks like your white becomes your red, your orange becomes your yellow, your shining yellow, your blue becomes light blue becomes shining yellow, and this and that. Okay, so we have successfully converted our HSV into we have converted our normal image into HSV. Now let's put a range, like if we have converted like this, but we want to put a range that this color need to be popped out from our image. So if we require brown color, then we have to define range for the color. We have to define certain values that, as we have seen in our PPT, that our image is represented like this. So if you put some values like something which is 8 greater than 83 should be sorted out, then all these values will be sorted out and then be displayed again on the screen in the color format. So I'll just name it. Let's try for the blue color. Let's see what we have here in SVR. In SVR we have, I think, blue color. Yeah, we have blue color written. Okay, so we have blue and purple things like that. So let's call for the blue color. So I'll just make it lower blue, we have to define certain range. Uh, that would be, what would that be? So we have to find lower blue and higher blue. As we have discussed that we can simply convert HSV, we can simply calculate HSV image values. So let's go to our PPT again and check for the conversion table. And for blue, we have 240, 100 and 100. So by dividing 240 by 2, we get 120. So I'll just put here 120 and put 50, 50. That can be, we have 120 as a base range. So I'll just take a value less than that and value more than that, and maximum in both the cases. Okay, so when I have defined range of colors, but I want to put these range of colors into my frame, into my variable in which I have stored images. So I will call mask. If we talk about mask, then it will differentiate the two, the in range what we have defined for the HSV format which we want to apply on. The lowest value will be lower blue and the high value will be higher blue. And done. So we have defined the range of colors which need to be sorted out. We have applied CV in range. If this color, if these values are in between or in greater than that, then it should display that. So let us see that how does this look like. I'll name it mask. Okay. Okay. So that is my normal. That is my HSV, and this is my black and white, and this one is my mask image. So if you compare the mask image, the black, this one here with uh, the blue and red one, then you can see that these purple color, I think these are purple, dark blue. These are sorted out. These are been taken care of. Light blue is not taken into consideration. So we are quite close to our goal that we can surely do this by defining certain range of values. Okay, if we try changing it, like if I gave it like 80, let's see if it gives different. Okay, so now when I have decreased the value of H, then I can see info tag is also printed. So it can take the light blue color also. So each color has values, and if we change the value according to our need, then it is workable. So when the mask thing I have done, but I want it to uh, make it more quite uh, favorable for my visualization for visual impact. So I'll just put another threshold here a bitwise, and I'll make it uh, my image code is source code is image, and I want to apply it on image, and mask should be supposed to mask. So this is another thing which I have applied. So let's see if what does bitwise and image do. So for that, we will simply say CV to IM show, and this will make it for bitwise. Let's call it bitwise, and I will make it addresses rest. Okay, so I have. Let's change the value again till what is required as of now for us. So now I see that. Let's see them in series. I have a normal image like this. I have a HSV image in this format. I have the mask image that in binary conversion of black and white, what is on my requirement. And then I have bitwise, which converts the required color into color format. Suppose if you're sorting two colors simultaneously, if you go for yellow and blue as well as for yellow as well as for blue, then both will appear into binary conversion like black and white. So you won't be able to differentiate that. In order to avoid that confusion and avoid that mistakes, we have applied for bitwise AND function to give quite a good result. Uh, we will be avoiding using black and white. I think that is not necessary. It is just creating confusion for us. So, so these are all the things which we applied. Now what I want to do is that my color combination is appearing to be quite rough. So I wanted to have a contour which we have talked. So I'll just make I'll just call for contours and I'll call for hierarchy. Oh, let's over hierarchy as well. And I have CV2 point. Okay, meanwhile, if you have any questions, you can surely drop them in chat box. Okay, so I'll just call for this function contours and I'll make CV2 find contour. So what this function will do, this function will find contours. So that is what is we require, and it will find in which image. If we suppose if we want to find in IMG, so I don't think it would be able to find that because IMG is full of colors. If we go for HSV, that would be hard. We have applied a range here for blue, then it should find its value in mask because mask is something which is different from blue, which is white and black. So it will find contours in mask source, and we have to fill certain different other formalities, which are the types and algorithms which it should apply. These can be changed. These can. Someone has a question.
इदं कवचं महाकवचं परेन्द्रः एकवारं जपेत् स्तोत्रं सर्वशत्रुनिवारणं द्विवारं तु पठेत् नित्यं सर्वसंस्कृतम्.
Yeah, muted.
Okay. Okay, so let's continue. We have applied contours applications here, and let's print the values of contours what we have find. So I'll just go for length and the values here, and let's see what I got. I got 2, so it has got 2 contours. And if you look into the images here, then I think this should be the one which we have got, and this should be the another. So that's coming quite perfect. We don't want to do any extra efforts in that. So that is the numbers, but I want it to be displayed also on the screen. Like it should be displayed on the photo, on the visual pictorials which we are watching. So I'll just make cv2.draw contours, and I want that contours to be drawn not on the mask, but I want that to be drawn on my real image. If suppose for a time being, let us put that into mask image, that the contour should be displayed here. So I'll just make here contours, and I'll just make here the width line, some other parameters which need to be set in order to define the results into presentable form. Like for example, we have to define the color which it would be using. So BGR. So let us define it with green color. I think that is quite differentiable color. Here we have one. So we have applied our theorem to, I think we have applied to the contours to mask. Okay, so mask here, here code again. We want it to be on IMG. Okay, so yes, is it I think it is. It might be visible from here that you have green color layer sorted at SVR logo here. If I increase the width to some more value so that it can be differentiable easily, let us just remove other uh, uh, frames which are not quite useful up now, but we have worked on them. We will just comment it out. Okay, so now this look quite fine. I think this is fine. That I have a length of like a width of 4, and it is quite covering the boundaries. So this comes out to be good. If I want to change the color for this, I can simply change the values here. That is all custom. This is all customized and can be uh, changed according to needs. Suppose if I change it to contours, change to blue color, so this appearance is blue. If I want it to some other like red, I think this should give the results. Okay, red. So as of now, let us give it green color. The reason why I prefer green is green, yellow. They are quite have a quite intensity in them, so they can be differentiated. And let us make it 2 for a proper definition and defining. Okay, so this should turn out to be good. Now, what we want to do is that we want that the contours which we have drawn should be giving us a center. Centers in the sense that we want that has to be having some point through which the robotic gripper should be taking into consideration that it should grip it in that way. Suppose if we have a circular object, then finding a center and gripping it from the robot from the gripper will be quite uh, simple. But if you have unsymmetrical objects, then we cannot carry or we cannot grip it from the boundaries. Otherwise, it might damage or it might damage the gripper or it might drop it to somewhere else, which might be more uh, not good sequence to follow. So to clear all them out, what we're gonna use is that we will find a point which is almost center, although whether a symmetrical or we have a symmetrical image, so that our gripper should grip it from that way. So to start with, uh, I will be writing CV2 dot circle, and that should be applied on the image which is IMG source, and that should be applied on contours, which we have contours, all the contours, and the circles are to be taken into the symmetrical as well as asymmetrical format. So they need to have some coordinates. Which coordinates they should be given. So before defining the contours, I have to first of all define the coordinates, that how the coordinates are obtained. For this purpose, I'll be using a function called image movement. Image movement takes out the point into whether they are uh, symmetrical or asymmetrical image. It takes out all of them into this. So if I say that put M into contours, and if I run this program, let's see what results do we get. Okay, so is it giving some error? Okay, so we have defined image movements, but we have not defined the coordinates in that case. So I'll just go for CX, and this is quite this is like calculations which are involved in this. So I'll go for int, and I'll go for M, the function which I'll be using, and the M10, and I'll be dividing this with a number that will be M00. That is something which is taking a circumference to a limit and then dividing and getting a center value for all the values concisely working on. So if you have like working on circumference, then it's taking a point one by one and then taking a center value for all the points simultaneously. So which will in thus make out our center to be quite potential enough to for a gripper to take a grip. So okay, so I have we have given for x and we will be writing for y. We're repeating the same steps. Just I'll go for m and the values here m01. The first one m10 is for x, taking x coordinates, and second one is for y. And we have m00. Okay, so it's giving some errors in CV2 movements contours. So it has to for I in for contour in contours. Okay, so let's see what does does it give any error. So it should be only contour. Okay, so it does not give any error, but I want to see that please print my the coordinates value which I have obtained here. So I want to see that yes, is it really having some impact on my working? Okay, so I got two values here, 145 and 126, as well as 35 and 123. But on the image, I don't know where it is. So I want to see it on the image. I want to print the coordinates on the image itself so that I have a better visuals. So for that, what we can do is that initially we will be making a circle. That circle, if you talk about circle, then we talk about radius and diameter. Okay, so if I talk about your solid circle, then you can precisely optimize it with the fact that it has a zero diameter. Okay, the solid circle is something which has zero diameter, or in simple terms, you can call it point. Okay, so I'll go for cv2.circle and I'll address it at img. I'll define the coordinates here, which I have got from image movement. And after that, I'll define some radius. That will be 1. As of now, let's see what do we get, and we can change it according to our need. Then let us define the color for our circle. And after that, let us define the shift, or let us define the thickness. So if I let's run the code, let's just see what we got. Okay, so I do see here some dots. I should increase the size at it might not be. Okay, I should increase to 20, I believe. That's too much. Okay, so as you can see, we have two dots in the center of S and R. So these are basically my coordinates which I have taken into consideration by defining the contours. So where each image can be taken into consideration and these algorithms can be applied. But I want it to look more quite realistic or good.
Sir, please.
Yes, ma'am.
Docs.
I'll just complete it first. Can I just write after that? Will that be okay? Okay, never mind.
Fine, that will be fine. If you want to complete the entire code and share, that would be fine.
Yeah, sure. So, okay, so we have seen a circle, but I want to make it like more presentable. So I'll just write something near the center. So let us go for CV to put text. So anything which involves OpenCV algorithms and you are applying it on the images, then it will be starting with CV2. As you can see, whether it is CV2 movements or CV2 IM show. In our case, new case, CV2 put text. So that text should be in the source image IMG, and I want to name it as center. Okay, and the center name should be to the location of TX and CY, and the font it should be the font it should be displayed will be CV2 dot font / simplex. Of course, you can change it whichever one you like. You can simply put it on. And there are some other parameters, font scale. Now again, we are dealing with color. I think we should make it red. That would be more good. So BGR. So we will be having 0, 0, 2, 5, 5. Okay. The next parameter it is calling is thickness. So we have to define the thickness for the text. I think we should avoid it writing anything. And let us see what we got get now. Okay, so let us write thickness also, I believe. So if this works, okay, so I have to let's make it 5 as of now. And also okay, so this might be look quite a small image, but let us for the prototype version see this and we will change it to something else. So we can see that we have green dots at the center and then we have center written here. So as this has already been visualized, I'll just make it a little bit normal looking, because when you have different types of images, when your centers making is too much. Okay, so this looks fine. However, a little bit light. Now what is happening is that I don't want it to, basically I cannot see where my center is, so I'll just make defer it a little bit, position differ for this for a better optimization. This is core optimization. Basically it won't create hindrance for your calculations or your process, but let us make it more good looking. Okay, so this turned out to be good. The two centers here at R and C are marked here with the name center, but still I think they are quite big in size. I'll just make it small. Okay, so they are quite small now, and we can, of course, we can customize the size according to our needs. But okay, let's proceed further. This was is something which we have applied uh, for blue color in our image. The centers are defined, their coordinates are noted, and we have for visual inspection we have put contours around it, and then we have marked it. We have named it as a center. So now let us take our other image and just change the address from here and see if our code is really workable in all images, or is it like just a one image which we have taken initially. So if I check the name here, it has two blues. So I'll make it two blues and let's run our code. Okay, so I think we have a code error here, but the code was not having any error when we have used strpng. However, it is calling out an error here. So the reason behind this is that the calculation involving C movement, if you look closely, that we divide something by something. So when two somethings are divided and one something is 0, then the value we get is not defined. So the error simply puts out the same thing, that float division by 0 is not possible. That is basically we cannot render it. So to avoid that, I'll just put a condition that if my m, I'm sorry, m, and the second value is m00. If my mm00 is not equal to 0, I'll put a colon here. Then I should perform this task. That if my number is not equal to 0, and I should print it afterwards only. But if they are but if it is equal to 0, then I don't want it to go through a calculative process. I want to simply make it cx and my cy as 0 and 0. Okay, so let us run our code again and see if there is any difference or we have eliminated the error. Okay, so we do see something here. The centers here are 1, 2, 3, 4, 5, 6, and quite many, I believe, and the green area is quite also parted, and the centers is also visualized and can be seen. But the problem is that we can our eyes can easily see that they are two different, but our program is making it appear to be like quite many. But there are only two. But it is showing like if we check the number of contours in the first line, I think there will be quite many. Let us type here print number of contours and let's see what we get. Okay, that would be 24, but we do not want 24 to be seen. So initially we'll be avoiding the use of 0, 0. So if there's 0, 0, they need not to be calculated, need not to be mentioned, because the 0, 0 condition occurs when this condition fails. Okay, so that could be avoided. What else we can do? We can avoid. Can you avoid something which is reflective here? Because the problem here is that the image is quite reflective. So I'll just make another logical assumption here. I'll just take consideration of the area concept, where cv2 dot area, that is contour area in contour. Just okay. So if area of contour and this, then I write it if area value is greater less than 100, then please continue. Or else what you have to do is you have to go through this draw contour process, and then you have to make it be favorable. So let us see now, does this have any changes on our code? Okay, show some indentation error. Okay, so I have to take this whole into a loop again. Okay, now I can see, yeah, number of centers are reduced and they are reduced to 2. And that is what is my particular quite, that is like 100% efficiency. But I still wonder why do I see number of lines that are so much entangled within themselves. I don't want to see them. I just want my two walls circumference and my something which is not affected as of now. If we take into wider condition about camera lights, their pixel megapixels and something like that, it should be a little bit workable. So what I will do now is that I'll just mm, make the draw contour concept not here, but after it has attained this step. So whenever if something having a zero value or something having low area, that would already be been skipped out, and I'll just make it contour because that our function will be working for contour, not contours, because we have taken all the contour in the form of we have taken all the contours in the form of contour. A letter S here makes a different. So let us see. So we see some difference after this. Okay, so this is bearable, I believe. This is like we can see two controls; they are totally fully workable, but not quite, which can be accepted. So I have to just to adjust the range for the colors. Let us now make it 70 again and see how does it differ. Okay, so this is perfect. This is what I was expecting. This is how my uh, code should work out. I was expecting two boards and I can see exactly two contours surrounding the balls and giving me perfect results. But what's important is here that after you have totally made your code, after you have totally applied all the theorems, algorithms, parameters, features for better optimization, visualization, their defects are avoided, their real conditions are taken into consideration, and the ideals are avoided. What's the most important priority is the values which you set here. So which can also change according to the lights and angles. So your workspace should be something which is defined by that. Your workspace which can be differentiated with that. So now I think this is fine. Now I think this is fine, and it should work on a video code. I don't know. Let's just see. Let's try one more time. Okay, it's coming now. Okay. Okay. Okay, so I'll just avoid this one. Okay. If I just try it one more time, just see that work. If I say video capture and I call for parenthesis and the video is not see something. Okay, never mind. We will just take a live example because there's problem with something with the video. It's not taking the input. Command is capture. Okay, let us just make it. Let us try just one time more about Okay, I'll just take another the same video again. I'll just make it copy. I'll just paste it here. Let us see if this gives us suggestion now. Okay, never mind. We'll just make it available for our real-time functioning for the webcam. We will be making it available. So have it image as we have seen. So I'll just put it on once again, and yes, this is workable. I believe this works fine. But after doing this, I have to again do the cap release. So I'll just make cam not release, or as we are working with one only, so it doesn't need to be done. Okay, so when this is done, we want our this to be represented into a live working. So as we have done previously about calling cam to CV2 video capture here, I'll just repeat that same thing here. I'll just comment it out first. Okay, so before converging to HSV, let us make call a cam, and I'll just make it CV2 dot video capture. Okay, CV2 dot video capture, and then I'll just my webcam address that is 0, as we have already discussed and done, and I will make this into a while loop so that the images which are coming into frames from my camera will be processed quite fast, so that it can be used as it can be seen as a video. So I'll make it available as 1, and then colon, of course. And another thing I was doing is that I'll just make it the first input unfunctional, and the second one will be taken into cam.red. Okay, so I've taken this, and the input here, the ownership here has been given here into the second value. So I'll just if we okay. So this all has to be in while loop. I'll just remove this, and this, so that it can be viewed easily and quite okay. So let us see that if we get results, or do we get some errors. Okay, so let's go. Okay, so this is currently my stuck face. I think we have not set the frame rates. That should be 1 to start with for maximum values we can attain. Okay, so I have this blue, and you can see that if I put my fingers on, then this has been totally been differentiated. And these all things are working in real life. You can see my movable hand, and you can see that how the blue area has been covered with the camera. But there are some other values also which are covered. My black hairs are also reflective. The brown fan is also reflective. So that is something that is like the errors which are uh, the noise which need to be cancelled out. And you can see that each dimension is showing us a center for its position. So if you put different blocks, then that will be very much quite realistic. If we talk about pad which has okay, this is giving fine results. Okay, so let me put it a little bit closer. Okay, so this is something uh, quite mesmerizing for me. Also, that it is giving perfect results, perfect boundaries, the moving motion, and all these things are working in real life. So the conclusion which we can draw from here is that the center's values the pixels values can be taken and can be visualized simultaneously. Visualization for the and use for the robot to go to the position. So if I close it up and let us what conclusion we can have here is from here is that we have coordinates available for us. So I'll just want these coordinates to be sent back to the robot. So continuing to my left out PPT, we have here 6J robotic arm. So when the coordinates are attained and achieved to the robot, what it does is that it basically gives the coordinates to the robot, and robot by inverse kinematics go to that position and pick up the object. But the problem here is that the pixels coordinates need to be converted into the real life coordinates, and these values depend upon the angle between the planes, that is the on which the objects are placed, and the plane which will be defined by the camera which we are using. So the distance between the two planes, the workspace and the camera, and the orientation and position alignment of the camera is important for the calculation. These things can be put through, and after that, the coordinates can be calculated on real life. I'm sorry, in real coordinates can be calculated and can be tested. So the workflow, if we talk about how the values goes from the camera to the PC, we have used a camera here. So camera gives input to the OpenCV running system, as you can see. So the OpenCV running system visualize it and give the coordinates to the PLC, because the PC and the robot can communicate through a PLC, but not directly. We do not have a communication protocol between them. So the OpenCV system, we have used Modbus library. For the Modbus library, what it does is that it basically gives put a value into registers of the PLC, and that values has been read by the that registers value has been read by the controllers and the by the robot controller. So the values which you need to be, suppose if we have 25 and 30 as an appearing values for the pixels, but in real coordinates they are 45 and 1 time. So these calculations is being done in an OpenCV environment only, so that we can just send the values here, and it can be calibrated in the it can be calibrated just in the OpenCV system. For we have a gripper which is controlled, and which is the open and close motion is controlled by an Arduino by a microcontroller for its functioning in order to grab the object and drop it. So this was the initial project setup what we have achieved, and this is like capturing images as we have seen live demo also. So that will be just a piece of prototype to start with. Then we can have the captured image is differentially put through in red. Suppose I think in this case we are sorting out red color. So the red color can be put through like this. This was a camera calibration video. We have performed 9-point calibration. It should be this much accurate. The keeper is put it through with a needle, and the exact point has to be noted. These are initial calculation which need to be done for his working. So basically the PLC is taken as a mode of communication for TCP/IP communication, which we have used. The reason behind taking PLC is that it's we have a voltage availability of 24 volt, and the working voltage is obtained through the controller, so we don't want to put an extra power source there. Uh, but if you talk about Arduino, that if we are already using a PLC, then why to use an Arduino? Because the both are the both are controllers. They both can be the one can do the work of two, both of them, and we do not have quite a lot of sensors or actuators that we need another controller. So there is a critical analysis here that your PLC cannot provide the PWM signal which is required by a servo motor. So for that purpose, we have the reason to prove that is we have to use Arduino. Second reason is that the power consumption, basically, if you try to put a code in PLC, then you can do that by putting values of PWM, but it won't rotate in anti-clockwise direction. For a gripper to open and close, you can open it, but you won't be able to close it with the same code. And if you switch to some other pin, then that might become a little bit complicated and uh, isn't giving good results because of the fact that the power supply needed for the servo is also quite high, and that is not available in case of PLC. So this is another reason that we have to use extra module and make it available here. Okay, so the conclusion which we can draw is that basically initially we take inputs from the camera, we put it into OpenCV, the coordinates are sent to PLC, which after that sent it to the robot. The arm converts the calibrated sequence and via reverse kinematic position itself to the location. After going to the location, it picks up the object and it drops into the required location, which is set by the user for different colored application. And this thing goes on and on until unless we have achieved a target, until unless all the balls are sorted out. So if we look into a video which is how the so this was the robot and we have camera placed above the workspace. It takes the object and block and keep it into the box. So we have to define 2-3 points before going to the workspace, because if you go directly to the location object tree to workspace, then that will be a little bit cringy sometimes because the robotic arm has to put through an acute angle to perform the task, and that might be not good for the robot. It might damage itself. So this is we have sorted initially for green color. This goes for blue. The color the sequence is blue, green, and red. BGR. So once all the same color objects are sorted, then it goes for the other one. This concept can be customized also, that it should first take red or first take blue, then take green, then red, and it should repeat the process until all one by one instead of taking all same color into consideration. That could also be done if we just place values the values which we have discussed for color sorting at the different levels, different parameters. So this was all about it. And if you have any questions, any doubts, you can surely drop them into the chat box. Any feedback will also be great.
Thank you, Piyush. I would now request participants if they have any questions, please put it up in chat or you can ask orally. In the meantime, Piyush, would you please again share the code, the final code that you had written, or is it closed?
Okay, sure. I'll just share this.
Thank you. So if any participant has any questions, I would request them to please feel free to ask the questions now.